Hey everybody, I wanted to go a little more farther into hydraulic steer and then we'll get into electric steer a little bit later on. Again, I was received a new PowerPoint and I will be actually putting it up on Canvas very shortly with this, this actual video presentation. Anyway, so let's go ahead and get started. Like always, I always like to start off with a PowerPoint and give a little bit of a discussion on what's going on in this. So let's go ahead and start the show. Okay, so hydraulic steering has been around for a long time. Before hydraulic steering, there was actually it was actually manual steering, and you had to be very upper body strength, a little bit strong. And I do have experience in this. When I was very young, I had just got my driver's license at 16. I was babysitting my cousins, and my mom was, I pretty much didn't have a car yet. I was borrowing my mom's car, but my mom had to use her car. So, and kind of, short to the chase here. My aunt decided to take me home. Well, she had an old Rambler, was manual steering and manual brakes, and she said, "Hey, you got your license? You want to drive?" And I said, "Sure." So I jumped in the car, and it was very stiff and steering. I was so used to my mom's Buick that had power everything on it. And I went to, and you had to have a little bit of upper body strength. But when I went to stop, I noticed something else. It took a lot of effort to stop the vehicle too. And I go to my aunt, Joyce, I said, "Aunt Joyce, I think there's something wrong with your car because it's really hard to stop." And she said, "No, that's the way it is. It's all manual and everything." So I learned my little stuff on manual brakes. But hydraulic, or sometimes they call it power assist steering, is a system that came out to assist with the operation of the steering. One of the things that we look at, and this is just a little bit of science here, is Pascal's Pascal's law. And Pascal's law, this actually also applies to any kind of hydraulics. So if I take a container, okay, and I have a fluid inside it and I put pressure on it, it's going to put pressure out equal in all directions. And this is what we do for steering. We use this principle to help with the assisting the steering. So this is just, when, like I said, when you get into your power steering and steering suspension, you're going to talk more about this. But Pascal's law applies not just to steering, but also with your brakes. And if you're working on any kind of hydraulic systems like lift gates, all this plays in place. And this is showing how that works too. So I have my fluid in here, I'm putting a little pressure on here, and it exerts that pressure out this way. If I can do it again, through a little tube here, and do it that way also. So I have 10 pounds of pressure going in, and I got 10 pounds of pressure going. Even your floor jacks, same principle when you're lifting up things. Here's another way of thinking about it too. I have different size cylinders, and this causes more output going. So I can take a 10 pound and I can cut it in half here and make it 5 pound output, 10 pound output, 20 output. Why is the purpose of power steering? It's actually to kind of help you with the driver to turn the wheel, so it's less effort and get the kind of the same response. So in the parts, there's going to be a power steering pump that actually applies that pressure, and there's going to be a reservoir where you're going to be checking, and it's important that you check that reservoir. Power steering fluid, for whatever reason people think it never wears out, it does. It breaks down after a period of time, and it should be changed on a regular basis. And go by what the manufacturer says to do. But and that reservoir is kind of just like your radiator or a reservoir. It's a reserved spot for the fluid to be in. So when it goes into work, you can actually see that fluid go down and up. And if you take the cap off, be very careful; it might splash over. you'll actually see it circulating a little bit too. So they can be, you know, right on top of the pump. There can be a reservoir. There can be a remote reservoir someplace else, because it's, you know, a lot of times it has to do with space. Okay, and it forces and pressurizes. You know, pressure is involved, and it's a lot of pressure, folks. So be very careful. We can actually have you know, forces of 450 psi when you're going into the parking, where it gets to the maximum. So you're at a dead stop and you're kind of parking it. It can actually be up to 1400 psi. So that can be very concerning. You know, there's different types of pumps. I won't go into all of the different ones, but there's vane type, you know, that actually uses centrifugal force to actually, you know, force that fluid around and pressurize it up. There is an actual control unit in, you know, that, you know, modulates, you know, the actual pressure. You know, bleeds off some of it. You don't want too much pressure, or else it can actually start blowing things out, seals, and blow hoses off too. This is what a pump, you know, this is one with a reservoir already on top. This is one style. It actually has the pressure hose coming out the backside here. Here's a return hose here. This O-ring seals this actual pump in place. And this is one of the kind of descriptions right here. And there's, like I said, there's different ones. You may have a, you know, cap on top of the pump, or you might have a remote reservoir like this one here. It's not on top of it, and it's primarily because of space. And all it does is actually, you know, fill and have the spot for that fluid to be at. So here are some different types of pumps. You know, you can actually see that this one has no reservoir. This has a reservoir in it, and this has a reservoir in it too. And like I said, there's different types of setups. This is a vane type pump here. You can see all the vanes. It goes inside this rotor assembly, and it kind of pressurizes around. And you can actually see that in action here. So here's how it phases in. And as it goes around, it's going to get, you know, give a little bit of pressure. And again, he's showing a little bit more of that. And then kind of following it out, it actually shows you how it spins around. Here's that little flow control valve to make sure it doesn't over pressurize. And if you do have one over, usually what happens first, it starts, you know, weeping through the seals, and after that it starts blowing the hoses apart. Usually those hoses are very high pressure hoses. You're not going to use a fuel line or anything like that. You're going to use a high pressure hose for that, because it could blow itself apart. But this is what's going to kind of control that pressure. And here's what it looks like inside. After a certain amount of pressure, it allows it to actually bleed off. So it doesn't, you know, it won't allow it to, you know, to overpressure. And it says, how does the vane type power string pump operate? And it's, you know, centrifugal force. Okay. You know, power string hoses, you know, like I said, very strong, put together. A lot of times they put a lot of metal into them. This is a good picture of one right here. So there's some rubber components. We do have to have some rubber part of it, because there is got to be a little bit of flexibility. If they were all solid mounted, you could have a hose break. But if I put a little bit of rubber in place of it, it can actually, you know, allow it to flex a little bit. And that's what they're looking at. And then some of the, you know, because the power steering fluid will get very hot. Some of the vehicles actually have a cooler attached to it to cool it down, because you get the fluid too hot, it has possibilities actually of the fluid breaking down the properties inside the fluid. So the integral power steering pump, you know, the control and the, you know, power piston, which applies force to the pitman arm, are, you know, actually incorporated into the steering gear itself. So there's the integral type, you know, and then there's a rotary control valve inside. So let's look at inside here. So here we're actually looking at a box like we've seen before. And it's, you know, it allows to help force that back and forth. and I should, force is probably a bad word, but it allows it to actually give assist when you're going back and forth. And here's actually the, the rotary type, setup here. And here we got to look over the top here. And this is helping with getting the straight ahead position going also. Again, you'll talk a lot more about this when you get into your steering class. This is kind of an overview of what this is all about. Here is another picture of it right here. And here is showing some more center action of it. Rack and pinion, again, there is manual rack and pinions out there now. We're primarily electric, which we'll be getting into next. But you can see how this control actually allows to assist in that rack going back and forth. So when you start turning this way, it's going to open a valve to help assist that motion. You turn it the opposite direction, it's going to help assist that motion too. There's a control valve. Here's that control valve to actually assist. This is showing, more of a steering gear type system, and actually it's in, inside, that actually valving assembly. So this is, when you're at low speeds, you're going to have a little bit more turning ability. When you're at high speeds, you don't want that quick as response, or else you're going to be really changing lanes real quick. So you want to have kind of a flow restriction, you might say. And this is kind of showing some of that. And then in variable, effort steering, same thing. It's all speed sensitive in the steering. And then there's some other, magnet, or this is, system uses a variable bidirectional magnet rotary actuator built into the steering rack. So it uses a different type of winding and all, so we're getting more into the electric steer type. Again, we'll get more into this as we go along, but this is actually a combination of two. Actually allows the fluid to actually go at different speeds. So without getting too deep into it, again, one of the important parts is if it is a hydraulic system and it has a belt driven, you want to make sure the belts are tight and in good shape, because that's going to affect your steering. If it is an electric hydraulic pump, then there's a different thing. You want to make sure you have power to the pump. There's a whole diagnostic routine on how to do that too. So, fluid, you want to make sure there's no air bleeding through, testing it, we do on occasion do power steering pressure tests, and this is just a generic way of looking at it. I wouldn't go by this 100%, but I would get to the manufacturer's way procedure for testing for pressures and what pressures they're looking for. So this is some pressure, generic pressure off of the actor. So straight ahead is saying 150 psi, slow turning 300, full all the way to the stops. And again, this can be a concern when you're actually working on the vehicle itself too. So this is power steering, and I'm going to go ahead and stop here. And then what we'll do, because I'm just going to get more and more deep and technical on it now, I will post this so you can feel free to look at it. And also, feel free to look at the Zoom presentation on this too. But if you, again, let's go ahead and stop it. If you have any questions, please feel free to inbox me. If it is a general question, feel free to reach out to your fellow students in the student lounge and ask questions. If I see that there's not an answer being given, I'll reach out, and then everybody will have the answer to the question you actually asked. All right, until next time, I will be talking to you. Take care now.